Hey there, my name is Vichas Muthumani and I will be talking through the implementation of the same denoising model, but this one was built using TensorFlow API. And I will be showing you the results of my training, and I will also be showing the output results, right? How good it is in denoising the signal. And finally, I will be showing a table that shows how training on MATLAB is compared to training with the TensorFlow API. Now we will define the basic architecture of the neural network. It has two parts to it. The first part consists of 6 CNN units, which are followed by an FCN stage. The code for the CNN unit is shown below. The first line of code is used to define the convolutional layer, and this layer contains the weights that we share across the inputs when we do the training. This layer is followed by a batch normalization layer. This layer does the normalization on the outputs from the previous layer. The purpose of doing this is to make the training to go a bit fast as a result of the normalization that we do. This layer is followed by a ReLU activation layer, and then the ReLU activation layer is followed by a pooling layer. This layer serves the purpose of sampling down the outputs from the ReLU activation layer, and then this output from the pooling layer, which is sampled down or downsampled, is sent to the next stage of our deep neural network pipeline. So this slide shows us the complete network. So the first part of the network is used for the purposes of doing feature selection and also to sample down the input. So once the downsample input is sent to the regression output, it does regression on it, and the final output we get would be a signal that has all the noise removed from it. So we will now have a look at the training results for my training run of the neural network. So if you look on the left, I'm actually showing the graph, which I got, say when I ran my training. The line in red is showing the value of the training MSE, whereas the line in blue is showing the value of the validation MSE. And as can be seen from the graph, when we first start the trainings, right, the values we get for the validation MSE is really very high. And as the number of epochs starts to go on and on, we see that the value of the validation MSE starts to drop. On the right, I've actually shown a snapshot of, say, my training run. If you look, you can see the value of the validation MSE has started to drop. And at around the 8th epoch, which I'll be showing with an arrow mark, all right? So you can see that the value of the validation MSE has dropped down to 0.136. All right, so now we will have a look at the output results of a newly trained neural network, all right? So the first thing I do is I send in an input signal to pass through my newly trained neural network, and that is shown in the box in plot 1 on the left. All right, so I send in a very noisy signal, and when this noisy signal is passed through the CNN, we get an output, and that output is shown in plot number 2. If you can see from plot number 2, most of the noise has been removed from the ECG sample, and you get a relatively noiseless signal from the CNN. So it has done a good job of denoising the sample which was fed in. So now, if we were to compare how this denoised sample is going to stack against the clean signal, right? So the signal which did not have any noise to begin with, you can see that signal in plot number 3, shown here. From plot 2 and plot 3, if you see, most of the important features of the signal, right? Say the drift and the flow, is maintained in both the denoised signal and in the clean signal which had no noise in it. So from this we can come to a conclusion that the CNN has done a decent job of removing the noise from a noisy ECG say signal. So the following slide shows the results of training runs that were done on the neural network on both MATLAB and for TensorFlow. I use the same hardware specs and the same number of epochs. I've listed out all the specs on the slide. All right. So when I did my training run, in terms of the validation MSE, so TensorFlow gave me 0.0646, but MATLAB gave me 0.4. If you look at the training times, so MATLAB was able to get its training done in 1 minute, 0.27, but TensorFlow took 3.7 minutes to do the same training.